Okay, well, thanks for asking me to discuss this paper. This is a fun paper to read because it challenges some of the conventional wisdom that from the previous literature. So it's a classic asset pricing question, of course. What's the role of discount rates compared to cash flows, right? So in the time series, it's a very large literature, and we found that discount rates really dominates cash flows, right? So that means in our models, the goal is to incorporate these time-varying expected returns. So in the cross-section, things look a little bit different, as Sean mentioned. So it's a Cohen et al. Paper found that cash flows actually matter more than discount rates. So I always wondered about that, how these can be reconciled. So I come back to that. So the current paper, kind of ohm, right? So Sean said that if you sort of revisit the Cohen et al. Methodology with a slightly different setup, you actually find a different result, that discount rates dominate cash flows also in the cross-section. So that's an interesting result. So I'm going to divide my discussion in these four points. Hopefully I'm going to get to the end, but we'll see. So in terms of estimation, so you can show that the variance decomposition is equal to some regression coefficients. And this can be estimated by a pooled OLS regression. So we regress future returns on past variables, right? So these betas have the interpretation of variance shares, okay? So of course, there are different ways to measure the importance of this cash flow and discount rate news. So for example, R squares might also be interesting. Is it just a different way to think about the importance of those two channels? So this is just one example from the paper. So if you do this, so you on the right-hand side, you use the price-to-book ratio. So that's the Cohen et al. Paper. You find that at different horizons, these discount rate betas, they are not that large. So it's like 10%, 20% in terms of the variance. Or if you look at the R square out of the pooled OLS regression, you get like 5 to 12%. So this is the sort of old conventional wisdom. And what Sean and his co-authors do is they use the price-to-earnings ratio instead of the price-to-book ratio. And they find very different results. So the discount rate betas are much larger, right? As are the implied R squares out of the pooled regression. So these are totally consistent, right? So this says that if you use the price-to-earnings ratio, you find a higher share of discount rate news. So the implication is this can only be if, as Sean said, is that the ROE is forecastable. So it would be nice to sort of have these results with the ROE as well. So I always found this Cohen variance decomposition a little hard to interpret because it mixes cross-sectional and time series dimensions, right? So on the one hand, you look at the cross-section of book-to-market ratios, but then it's a cross-section of time series coefficients, if you will, okay? So I will go back a little bit and think about this as pure forecasting regressions, as Sean mentioned, right? So in terms of forecasting regressions, if you run a pooled OLS, the implied beta is identical for all portfolios, right? That's sort of the restriction of the pooled OLS. However, we know that conceptually, these discount rate and cash flow channels might differ for different portfolios, right? So if you have a value portfolio, you might get different cash flow to discount rate channels than for, let's say, a growth portfolio. So there are some papers that actually exploit this difference, right, to explain unconditional risk premia. So it's this good beta paper. So it's the whole idea. So what I will do next is, instead of running this pooled regression, I will run separate regression, time series regression for each of the 5 portfolios. So if you do that, you get, for the price-to-earnings ratio, you get the familiar pattern, right? So this is the discount rate beta for different horizons. So one thing is you see here is that the the low book-to-market portfolio has by far the highest discount rate forecastability using the PE ratios, and the other ones are sort of more muted. So a lot of these high discount rate betas might be due to the so low book-to-market growth portfolio. Now what's interesting is if you do the same thing for the price-to-book ratio, you actually get very similar results. So in the time series regression, if you run this portfolio by portfolio, the pattern of the discount rate betas for the price-to-earnings ratio and price-to-book ratio actually look very much alike. In fact, if you look at the means across all these 5 portfolios, you actually find higher discount rate betas for the price-to-book ratio as opposed to the price-to-earnings ratio. So, so here, in some sense, we find this disconnect between the time series, right, when we do it portfolio by portfolio, and the cross-section is what Sean was saying, right? So in the cross-section, we find that the discount rate beta for the price-to-book ratio is much smaller than for the price-to-earnings ratio. But in the pure time series sense, they actually look very much alike, okay? So you can also do this in the context of pooled regression. If you include portfolio fixed effects, what you recover is a much larger price-to-book discount rate beta compared to the price-to-earnings ratio, right? And if you sort of compare these estimates from the portfolio fixed effects, you see those match up very nicely with the pure regressions. So here, what I find intriguing is that we get this disconnect between the cross-section and the time series, right? These roles of discount rate beta, discount rates and cash flows look very, very differently. And in particular, the behavior of the price-to-book ratio and the price-to-earnings ratio also looks very different. So I think that's something that I think that should be explored a bit more. In some sense, what kind of model conceptually would reconcile these two sort of different findings, right? So, what I would like sort of to see going forward is to take these results seriously in the time series and the cross-section and try to figure out what kind of model of fundamentals, cash flows, and so on, and risk premia would account for these, for both time series and cross-sectional results jointly, right? So in some sense, it's like reverse engineering, right? So what would be a reduced form model that reconciles these two effects, okay? And so this is related to these to the models that Sean mentioned. So for example, my paper with Jessica, we looked really at more the time series dimension, right? So in some sense, our model fits the time series dimension, but it doesn't fit the cross-sectional variance decompositions. So it's a challenge, right? So, so I think that's sort of the big picture comment is to sort of push this, try to reconcile the time series and the cross-sectional dimension. I think that's a very intriguing set of results. So I think no discussion would be complete without some comments on the standard errors, right? So implicitly, so in long horizon regressions, there's a long literature. We know there's overlap that imposes serious serial correlation in the errors. And there are many, many ways to correct the standard errors. So in the panel regression here, the autocorrelation of the time series aspect is like up to 0.8. So we get very serious serial correlation, right? So, however, if I understand correctly, you only cluster the errors by year, but you don't correct for the horizon. I might be wrong.
Yeah, we do block bootstrap.
Okay, so so I come back to that. I was surprised that the standard errors do not increase with the horizon. So it's typical in all long horizon regression that the standard errors increase with the horizon. So you don't get that here. I was wondering why. Okay. So I'm going to skip this. So one thing that I think should also be explored a little bit more, and the paper goes into this in in some details, but it is about the time variation of these effects. So in the paper, they demean every year. So in some sense, the level effect are taken out. But if you just plot the cross-sectional variance of the book-to-market ratio, so you see this decline, this increase starting around 1990, right? So the cross-sectional distribution of the book-to-market ratios has increased. If you do the same thing, so it's like has doubled, roughly doubled a bit from 1980 if you just draw a line. If you do the same thing for the earnings to price ratio, you get actually a secular increase over time. So another interesting question is, A, why do we see this increase in the cross-sectional variance? And why does the book-to-market ratio look sort of different from the earnings to price ratio? So I think, so exploring these trends or this behavior over time is also very interesting, right? So it's, this is a factor of 4, right? So it's an enormous increase in the cross-sectional distribution of the earnings to price ratio. So I think it's, and since you, in some sense, you look at regression coefficients, so covariance divided by variance, this is taken out. So I think it's another interesting question. Is this my phone? Okay, sorry. Another interesting aspect in terms of time variation is the distribution. So if you do this on a rolling, if you do this on a rolling 10-year window, you see there's time variation in the cash flow to discount rate channels. So they argue that for the most part in the sample, the discount rate effect still dominates the cash flow effects. However, they use sort of, within windows, the weights are declining geometrically. So, you know, if you do this with equal weighting, so you, in each window, you equal weight it, right? Then you get a slightly different picture, right? So there's a really significant time variation. And from 1990 to 2000, you actually get the opposite effect, right? So I think there's also very interesting time variation in the coefficients over time. Now, why is that? Why do we see these cash flow and discount rate channels differ over time? So I think that this is also another aspect that I think is interesting to explore further. For the R-square, you get a similar picture. So, right, so that's the bottom line. So one issue with this methodology is because you can't rebalance the portfolio. You have to track the firms. In some sense, when you have very long horizons, you lose a lot of firms that drop out, right? So in some sense, the coefficients are based across different horizons are based on different firms in the portfolios. So this could be selection bias because large firms are more likely to survive than small firms, right? Since they use value-weighted portfolio, this might be small, but I think it's important to document, you know, the sort of how many stocks drop out and so on, right? So thank you. I do very much like their firm level variance decomposition because it's sort of it circumvents this issue. So the conclusion, I'm running out of time, so you can peruse this. I think it's an interesting paper that sort of, in some sense, raises more questions than answers, which I think is good for a paper to do, right? So I think the two main comments are reconcile the time series in cross-sectional dimensions and then explore the time variation further. But nice paper, thank you.